All right, so one of the first things we need to do is just assess our data to see how it's looking. A great way to do that is to use the Explore feature that's found underneath Descriptive Statistics. So go to Analyze, Descriptive Statistics, and Explore. In here we can check things like the accuracy of the data file. We can assess for how much missing data our variables have, and we can look for issues regarding normality. At least get a cursory look at that. Let's just grab a couple of variables. We'll look at social support, SPSS. We'll look at the negative cognitions. And let's pull over the CESD. Just grab a couple of variables just to see how they look. Now, we'll want to go in here and let's go to plots. I don't really care for a stem and leaf plot. You can get one. I prefer a histogram. And then we'll also look for normality plots with tests. That'll help us check for any issues with normality. At that point, we're good to say OK. Under options, we can tell it whether we want to exclude listwise, pairwise, or to report the values. If we're running a statistic, say a multiple regression or a MANOVA, going ahead and excluding listwise is probably the best way to go. That way it's going to make sure that the actual cases that will be included in your analysis are the ones that we're looking at. So we'll go ahead and exclude listwise. And whether you're looking at independent or dependent variables, when you're using the Explore feature, everything goes under the dependent list. All your continuously scaled variables go into the dependent list. We'll look at all of them together. Takes a minute. Explore definitely takes a while to run. It's creating a lot of graphs and charts, and that always takes a while. So here we can see that we have 153 cases listwise out of 266. That's only 57% of our data is valid. We have 42.5% of our data is missing, 113 cases. So we're going to want to look more at that. So that helps us with our missing data issue. We can also get for each one of these just to sort of check the accuracy of the data overall. We can check the minimum and maximum values to make sure those are within range. Say we know on the MSPSS that scores can range from 1 to 20. Our scores of 1.4 and 7 are certainly within range. If instead we knew that the scores on the MSPSS should only go from 1 to 5, then we'd know we have a problem on that variable, that the 7 should not be there. We'd know to go back and look for it. The other thing we can check are just some basics on skewness and kurtosis to give us an idea of normality. So here we'll have our skewness statistic, which is much larger than the standard error for the skewness statistic. So I'm a little worried about that variable. I'm less worried about this PTCI NCW variable. That's not that much larger than that. And our kurtosis is about less than three times the size of its standard error. CESD, I'm a little bit more of an issue on. And as we can see, the statistics, the tests for normality, if we use the first one, and we use a very stringent, or a very liberal, alpha level of 0.001, this is over that. So this is within range for normality, this variable is. The others of these are not within range for normality. We certainly want to be worried about those. If I look at this histogram, this is for the MSPSS. I don't think anybody's going to look at that and think that looks normally distributed. That is clearly negatively skewed. And we can also see that on its QQ plot, which is a lot like a PP plot. We want those dots to line up on that diagonal. If we come down here, we have the histogram for the NCW. It looks better. It doesn't look normally distributed, but it looks much better than the MSPSS. And again, its QQ plot. We want those to hug the line. They're not quite there, but they're not too far off. And the CESD looks anything but normally distributed. Definitely has some positive skewness going on, but it also has that little bit on the left-hand side, and its QQ plot looks pretty poor. So now let's see what we can do about that.